How's it going, guys? So we're here at Unit 7 now, structural shapes. So this is really just profiles of material. So if you're in the fabrication class right now, you've probably you're going to be pretty familiar with most of this stuff. Or if you're in the structural class, probably the same thing. If you've had some of those CAD classes that might be required. So this one should be a pretty easy, pretty simple unit to get through. So some of the objectives here are going to be to identify the components of various metal shapes. Again, just kind of the general profile of the material. And then differentiate between bar-sized and structural-sized shapes. Determine shape size with correct sizing methods. And then go over a few of like the governing bodies, the standard code writers. Okay, so our first shape is angle. I'm sure everybody has seen or worked with angle iron. All right, this is the L-shaped material. Can consist of equal or unequal leg lengths, and that is how it's measured. So if you're looking at this measurement, if you're measuring angle iron, this should be the way you format it. So leg, thickness, and then length. Length always comes last. So keep that in mind on like your bill of materials, your material cut list, things like that. This would be the proper formatting: is leg, thickness, length. So angle iron is great as like a support member. They get used in structural situations as like gussets and braces and things like that pretty commonly. It produces really rigid form of like a stiffener. So you'll see these used on a lot of like I-beams and things like that. So pretty common shape there. Then we have T-material. This is one of the more uncommon shapes you don't see a whole lot of. Also used a lot like stiffeners and gussets when we're doing like building erections and things like that. So obviously it gets its name from its T-like shape. Okay, and this is measured by nominal depth of stem, which would be the vertical part, and the flange width, which would be the top, and then the thickness of both. All right, so flange, stem, thickness, and then again length is always last. So this can be classified as either bar stock or structural stock. So the difference between bar stock and structural stock is bar stock. That's your more like lighter material, like the tubing, things like that, sheet metal. So the more kind of fabrication, light duty kind of stuff. And the structural stock is going to be where you have your beams, your plate, all the heavy duty meant for structural welding, building erection, things like that. So that's going to be your structural stock, and bar stock is going to be like your tubing and your light duty angle irons and things like that. So channel, C channel. All right. This is also a very common shape. Built a lot of trailers with this stuff. So I've got plenty of projects that I built out of C channel. Very common shape, very structurally sound. So this is one primary type of a structural channel, but several types exist. You get them in all sorts of different kind of lengths and sizes. You can get like a half-inch flange by 2-inch stem by 3-inch flange. Like you can go pretty wild. You can change the web thickness. You can change the profile, the radius of the web itself. So channel can get pretty customized. But they're all C channel. All right, there's subcategories, but it's all channel. Okay, so all types of channel have the same parts, right? It's going to have a web, which is the vertical, and two flanges, the two legs you see coming off. The flanges of the structural channels are thicker at the web than they are at the outer edges. So they come in and they're not perfectly 90 degrees. They kind of come in at an angle off of the web. So again, the measurement would be depth of web, thickness of web, and flange width. All right. This type of structural channel is designated by letters in front of depth. So C indicates standard channel. It's the most common type. And then MC indicates miscellaneous channel. So junior channels and ship and car channels, so just different styles. So it's still a C channel, but it's going to have like a different measurement profiles. So beams, we got several types of beams used out in industry. So what most people, right, look at this and say it's an I-beam or a W-beam, which would be a little more accurate. But commonly it's just an S-beam. It's a standard beam. All right. But then we do have a W-beam or WF beam. It's a wide flange beam, also known as H-beams, or sometimes called a Bethlehem beams. And then H-beams are similar, but a little different. We'll go over that in a later slide. And then M is miscellaneous. So an M-beam is kind of, again, those oblong kind of profile dimensions. So W-beams can get welded together from 3 pieces of flat bar stock in the shape of a wide flange beam. 2 pieces of C channel can be welded together web to web to form an S beam. So that'd be like getting 2 C channels and welding the toes together to make almost like a weird shaped tubing that was a box but hollow through the center. All right, that would be called an S beam. So for it to be considered a beam, they have to have 2 flanges and flanges connected by a web. All right, because these are all, that's kind of the structural shape, right, requires the flanges and stems. Okay, so right here, this would be the W or WF beam, and this would be your S beam. Okay, so notice the profile. This has more of a chamfer to it. It's angled versus this, it's flat. Okay, this is like 90-degree all the way. All right, so that's the primary difference between a W or a standard beam. Okay, so a standard beam has about a 10-degree slope on each flange, whereas like you could see in the pictures, they have a just straight across thickness. So an M beam is just like a standard beam, but those flanges are going to have more than a 10-degree slope to it. And then there's pile beams, known as HP beams. So they resemble a wide flange beams, but the web and the thickness of the flange are always going to be the same. So with a W beam, you can get different sized flanges and webs. But with a pile beam, if it's 3/8 pile beam, it's going to be 3/8 web and flange. So tubing, again, now we're back into that bar stock versus the structural stock. So this would be more like the bar stock. So you can get tubing in round, square, or rectangular shaped materials. This is going to be hollow, but you should never use this to move fluids or gases. That's what pipe would be for. That's what it's designed for, intended for. Tubing is not meant for that. Tubing is not structural. It's meant more for fabrication. Okay, so larger sizes can be found being used as columns in buildings. All right, so you know there's still crossover there between the bar stock and the structural. And then round tubing. So this looks similar to pipe, but the wall thickness is thinner. Okay, and then tubing, you're always going to measure OD or outside diameter, and pipe, you're always going to measure it by inside diameter and schedule. All right. So here is tubing, right? Wall thickness, 4 inches by 11 gauge. And then length last. Okay, rectangle tubing, square tubing. Okay, they're going width is edge to edge, outside diameter to outside diameter. And then wall thickness and length. So the dimensions or the walls of the tubing is considered sheet if it's less than 3/16. Okay, and so to measure that, we could use a sheet metal gauge, which is this tool right here. Again, if you're in that fabrication class, you've probably used this for some of your projects. You can see there's all these notches in there, and you can just slide that piece of sheet metal in there, and it will tell you roughly. I mean, you'll know if it's that right size, what gauge. And if you flip this over, it'll give you the equivalent of whatever gauge in the form of a decimal, fractional decimal. So for instance, 12 gauge is going to be 0.105, and then 10 gauge is going to be 0.135. So both of them right around an eighth of an inch, but 10 gauge just over and 12 gauge a little less. But you could use this gauge if you had no idea what you were looking at, you couldn't tell. Maybe you got a sheet donated and there was no color coding on it at this point, and you wanted to not guesstimate the thickness, then you get one of these sheet metal gauges, put it up on there, and boom, now you know. Okay, pipe. So round shape, just like tubing can be, but this is structural stock now. All right. So smaller pipe is measured using nominal inside diameter and identified as nominal pipe size. So NPS, that's what NPS means. If you're ever at the hardware store, all right, and you're asking for a pipe, and you see this NPS next to the size, that's what that means, nominal pipe size. So NPS is the same as inside diameter for pipe up to 12 inches. So this NPS is only up to 12 inches. The higher the schedule number, measures less on the inside than the actual pipe size. All right. So that means when it's talking about schedule, that's the wall thickness. So the wall thickness is measured as a schedule. And depending on the diameter of the pipe and the wall schedule, the ID and OD, or the ID changes a little bit. The OD stays the same. So pipe greater than 12 inches is measured outside to outside. And then again, wall thickness of a given pipe can change. This is based on the schedule, right? If you've ever heard the term Schedule 40 pipe, Schedule 60, Schedule 80 pipe, all right, that's all pertaining to the wall thickness. So engineers select wall thickness that provides adequate strength for the amount of pressure and stress pipe will sustain, because pipe is meant for carrying gases and liquids, high pressure gases and liquids. So engineers kind of already standardize schedule and diameter sizes for pipe. Okay, so ANSI, right, those same people that write the safety rules for your safety glasses, they classify pipe wall thickness using the schedule number. Okay, so this is a formula used intended to service pressure and allowable stress, again for high pressure liquid and gases. Increasing the schedule causes increasing the wall thickness increases the schedule number. All right, and the wall thickness increases to accommodate higher pressure and stress values. So it's all based on pressure and stress. The wall thickness of a given schedule number varies depending on nominal pipe size. So again, a 6-inch Schedule 40 pipe is going to have a different measurement than a 6-inch Schedule 80 pipe. So as nominal pipe size increases, the wall thickness increases. Given schedule number, a given schedule number represents specific service pressure and allowable stress. So that's why for certain applications like low pressure versus high pressure, there's already kind of like a given, like you're going to be using this schedule and this diameter. It's already been pre-engineered depending on the pressures you need. Right? So if you needed more pressure, and you needed to like upgrade your pipeline system, maybe like a steam generator at a power plant, you would need to go greater diameter or greater schedule number to increase the capable pressures. And volume also plays a role in that. So the ASTM and ASME classify pipe wall thickness as standard, STD, extra strong, XS, and double extra strong. So you've got your schedule, and then you also have your standard, extra strong, and extra strong, which also changes the wall thickness. So you've got a few things. It gets a little confusing with pipe. You get a few things that kind of start changing the ID and the wall thickness, even if it's still a 6-inch pipe. So these are just things you got to look out for when you're looking into buying pipe. Okay, so bar stock. So this is solid material in shapes including square, flat, hexagonal, octagonal, and round. So that's all considered bar stock if it is solid. If it's hollow, it's going to be either pipe or tubing. All right, square and flat sized by width and thickness, and then hexagonal, octagonal, and round sizes are measured by diameter. Okay, so hexagonal, it's not, really a diameter, quote unquote diameter, but that's just from the widest flat spot to the widest flat spot. So that would be considered a 1 inch by 12 foot hexagonal bar. Okay, just like a 1 inch pipe. So you're only taking the measurement of those two flat spots. Same with the octagonal. And then obviously for round, you're going to get the actual diameter for that. And then your flat stock, so just width, thickness, length. And then same for square, width, thickness, and length. Okay, so bar stock, you can get this hot rolled or cold rolled. Okay, so hot rolled steel is formed while the temperature of steel is above 1700 degrees. That comes out with all the mill scale still on it, which is handy when you're, moving a lot of material around. This keeps it from kind of getting oxidized and ruined out in the weather, especially the mild steels. So hot rolled is definitely a lot more common. Cold finish, or cold rolled, receives a special grinding or polishing afterwards to remove that mill scale. So you're getting bare material. So usually they spray like an oil or a film or something on it, unless otherwise specified, to keep it from flash rusting in transportation. But it comes with the mill scale already removed. So yeah, that hot rolled still has gray mill scale. Sometimes it kind of looks a little bluish. And that comes from the foundry like that, and the corners of the stock have a slight radius. Cold finished or cold rolled steel is clean and has very square. They're a lot more accurate dimensionally than the hot rolled, because they're getting that grinding finish. So it's a little closer to being like a machined piece of material versus just coming out of the rollers at 1700 degrees. Okay, so plate, this is still 3/16 inches and thicker. All right, so it is considered plate if it is 3/16 inch and thicker, and wider than 12 inches. Okay, but most commonly just above 3/16, it's usually plate. Treat it like plate. And this is just measured by thickness and then width and length. Again, length, linear feet, how long that piece is, always going to be last. So for plate, I'm going to have a 1/4 inch by 4 foot. So that's just saying this is a 4 by 4 plate, okay? Or I could get a 1/4 inch 4 by 8, right? So sheet. So this is still thinner than 3/16. All right. This can be purchased again as hot rolled or cold rolled. If you've done any of the TIG weldings in the class, I'm sure you understand the difference between the hot rolled and the cold rolled. I'm sure some of you guys have probably tried welding on the hot rolled and gotten all that nasty porosity. Again, that's the difference between mill scale, which is a lot of impurities, it's dirty, and that cold rolled, which is clean metal, just bare metal. This can be reinforced with certain forming or shaping. So sheet metal forming, things like that, you can form structural shapes out of it. Think about like ducting for HVAC. A lot of that starts off flat and gets rolled into that shape. So that would be a structural shape, or just making like a fire pit, something that starts off as a flat piece of plate. And if you do like a hexagonal shape or something like that, a little more ornamental, once you get it all bent, that stiffens the metal up significantly.